Good afternoon, my YouTube viewers. Crystal here. I just wanted to make a new video for you of a program that I've been working on for 2 days, for which I'm going to make a blog post. I would like to say that the more complicated my programs are, the longer it takes me to write the programs and the longer it takes me to write the blog post. But I want to go ahead and make this video anyway, because we're talking about COV19. Now, what happened was I decided that I wanted to make videos on things that people would be interested in, and since people are interested in current events, since COV19 is a current event, I decided that's what I would do. So what we'll do now is we'll go over the program that I've written about COV19, and you can tell me what you think. This is, I've worked on it for about 2 days, so it's taking me a long time to work on it and decide what I wanted to do and how I wanted to do it, and I had to research a lot of code in order to do it. I've got my data set off of the website Our World in Data, and it's a downloadable CSV file about all of the data for all of the countries on this planet concerning COV19. But the thing is that this data set is updated daily. So every day that you work on COV19, you have to download the most current data set. So today I'm working on the most current version of the data set, which I downloaded today. And so I intend to be making a blog post on it today as well, since it's the most current version of the data set. So what we did was we wrote this program on Google Colab, and Google Colab is an online Jupyter notebook that has a lot of the libraries already installed on it. So all I had to do was I had to import pandas and NumPy. And after I imported pandas and NumPy, I imported the most recent version of this data set that I stored on my Google Drive, because it's too big for me to store on a GitHub account. Although I understand that there is actually a version of a COV19 CSV file on a GitHub account, but I just made the decision to store it on my personal Google Drive. So here you can see the CSV file that we downloaded in red. You can see we did information on it. So we've got 51 columns full of information. Most of it's numeric, but some of it is floats. So what we wanted to do is, one of the first things that we want to do is we want to convert the date to a number. So training date equals PD to date time. Train date errors equals coerce. Train date num equals train date. DT to strf time, and then the format they want you to use, and train. So you can see now what we've done is we've converted the date to the number, and I can show you here how we did it. So now we have a new column called date num, and this date has been converted to a number. The next thing we wanted to do is we wanted to talk about the country, because we want to know what country it is that we're dealing with. So country equals train location to list. So we put the country in a list. And now what we're going to do is we're going to remove any duplicates. So list country equals close brackets for I in country. If I not in list country dot append I, and now you do list country. So this is a list of all the countries that are actually in the data set. And I wanted to print the length of the list and it's 192. So somehow or other, an extra country got put in there that's not actually in the current CSV file, and I'm not sure exactly why that is. So now what we want to do is we want to get the latest date. So the last date equals date max, and then you look at the last date was 2020-12-26, and that was yesterday, Boxing Day, because I uploaded the most current version of the CSV file today. So we wanted to find out what type of cell this last date is, and it's a string. So now what we want to do is we want to convert this string to a date time format. So we have to import date time from date time, and then we format it. And so dt equals date time dot strip time last date format, and you print date time, and it says 2020-12-26. So that's the format that date time wants to see. So now what we want to do is we want to get the next day. So the next day is today, 27 December 2020. So next day equals dt plus time delta days equal 1, print next day. So next day is today, 2020-12-27. So what we do now is we say last date equals train.date equals train.date max last date. So now you can see this is your last date, and what this is this is a slice of the data frame where it gives you all this information that you're looking for, including date num, and it says now it's got 53 columns. 191 rows by 53 columns. So we missed a row somewhere. I'm not sure exactly why that is, but we did miss a row somewhere. So now what we want to do is we want to graphically represent our data. So we have a graphical representation of new cases, a graphical representation of new deaths. And now what we do is we wanted to check what the new cases are based on the location, but unfortunately there's so many locations. There's 191. It's difficult to make out the little chart that we've made. You probably would have to do a group by. And we've done another chart on deaths based on location, but again, because there's so many locations, it's hard to make it out. Now what we've done is we've done a box plot based upon the continent, so you can see the different continents. You've got Asia, Europe, Africa, North America, South America, and Oceania. So we've got the most cases of COV19 in North America, but I suspect that's because they're doing the most testing. And so now what we're doing is we're checking the deaths according to the continent. So again, you've got it looks like the most deaths are in North America, but you have a few outliers in South America. But again, I think that's because they're doing more testing in North America. And now, if you like looking at heat maps, I've made a heat map where the independent variables are relating to the dependent variables. So you can check that out and see how each independent variable relates in the data set. If you're really into heat maps, then that's a good thing to look at. Now what we wanted to do was we wanted to look a little bit at the UK. So what we've done is from this data frame, we've just sliced out the UK. So country equals United Kingdom, include UK equals train location dot values equals country, exclude UK equals train location dot values does not equal country, and then UK COVID-19 equals include UK and UK COVID-19. So you can see that's the data frame. So what we've done here is we've got a data frame of the UK new cases. So you can see that when they started taking statistics on this in the beginning of 2020, they didn't have a lot of cases. And then they had a spike. And so they decided to have a lockdown to try to correct the spike. So they had the spike, and that corrected a lot of the cases, and then the cases went down again. And you can see that now we're getting into the current day, the cases have escalated greatly. So we had a lockdown in November, and this lockdown in November that lasted a month, it decreased the cases, but then the cases have come up again. The reason why that is because the COV19 has mutated. The mutation has come out of London, and because the mutation has come out of London, we've got a lot of cases. So you can look at the deaths in the UK, and you can see that in the very beginning, they had a lot of deaths, and then the deaths went down to a manageable level, and now the deaths are starting to go up again, which is why we're having a lockdown, because the NHS can't cope with the number of people who have COVID and the medical treatment that they need because they have COVID. So now what I wanted to do is I wanted to do another one, and I wanted to call it UK new deaths per million. And so in the beginning of the pandemic, we had a lot of deaths per million. And so then they had the lockdown to try to save the NHS, because NHS can't cope with all of these people with COVID. And then so the lockdown helped decrease the deaths. It went down to a manageable level, and then we have this situation where this COV19 has mutated, and it's become a lot more infectious than it previously had become. So now we're having more deaths now, but not as many deaths as they originally had when they had the first lockdown. And the reason why we're not having as many deaths is because they initiated a second lockdown, and now we're on a tier system. And in Reading, the town I live in, we're under tier 4, which is pretty much a lockdown. So now what we want to do is we want to look at the United States, because I wanted to compare the UK and the US. And so here's the United States, the data frame. It's a slice of the main data frame that you can see. And so now what we do is we have a graph of the new cases in the US. And so again, in the beginning in the US, they didn't have a lot of cases, and then it escalated. And it seems to me like the cases in the US are continuously increasing, but I think that is a lot to do with the fact that more people are being tested. Now what we want to do is we want to look at the deaths in the US. And again, in the beginning we didn't have any deaths, and then it made a very sharp increase. And again, we've had a lot of deaths in the UK. It did have a decrease, and it escalated a bit, and then now it's going up again. And I think that's to do with the fact that this COV19 we've got 3 mutated strains of it. Definitely the one coming out of London and the one coming out of South Africa are much more infectious than the initial strain. And there's also a third strain somewhere in North Africa that it originated, but I don't know how infectious it is. But so far we've got 3 mutated strains. And now what we wanted to do is we wanted to look at the death per million. And so the death per million is the chart that's being developed is similar to the deaths. But if we look at it here, we'll see that the death per million is increasingly going up. But what I want to do is I want to go back to the UK. And you can see in the UK, the deaths per million, it does not look like, well, it says the UK, they give you a scale going all the way up to 17.5. And so it's about anywhere from 10 to 12.5 at the moment. That's what you got in the UK. And in the US, the scale goes up to 10. So I think it's a little bit misleading because the scales are not the same. The scales for the US is smaller than the scale for the UK because the UK goes up to 17.5, the US goes up to 10. So it looks like there are not as many deaths in the per million in the US as there are in the UK, but it's misleading because the chart's not numbered the same. So that's another thing that you need to take into consideration when you're looking at all these charts. You need to say, well, are we on the same sheet? Are we working from the same sheet? And obviously, you're not looking from the same sheet. So that's something. I'm going to do another program where I'm going to compare the deaths and the cases of the US to the UK and see which one is faring worse. And then we'll have to compare cases per million because that tells you what the situation is. So now what we want to do is we want to check for null values. You see that we've got a lot of null values here. We want to impute those missing values. So what we have done is we've dropped our date from the train file. And then what we've done is we wanted to check which columns are not numeric. And so we checked to see which columns are not numeric. All of the columns that were not numeric, we filled in A with not listed. And now what we do is we impute the numeric columns with 0. So since all of the non-numeric columns have already been imputed, then all you have to do is say train.fill in A 0 in place equals true. And now what we want to do is we want to ordinal encode this data set. So we put the data set on an ordinal encoder. And then after that, what we do is we want to define X and Y. Now, Y is going to be a multi-output target of new cases and new deaths. And X is going to be the train file, but it's going to have a lot of columns removed. So all of the columns relating to cases and death are going to be removed because we want to take away that variable so to form our prediction. Now we put X on a standard scalar, so X equals scalar fit transform X, and so you can see Y, and now you can see X because it's been scaled. Next thing we're going to do is we're going to split our X data set up for training and testing. So X train, X val, Y train, Y val. It was train test split, X, Y, test size equals 0.10, random state equals 1, shuffle equals true. Now what we want to do is we want to select our model. So I selected Hist gradient boosting regressor because it's designed for large data sets. And I got a 99.24% accuracy when I trained and fitted the model. And now what we're going to do is we're going to predict on the validation set. So ypred equals model.predict xval, ypred equals ypred.astype int, ypred less than 0 equals 0, and then we print our scores. So we got an 86.38% accuracy when we predicted on the validation set. And so you can see the validation set that we put it on a data frame. No, we didn't. We did put it on a data frame, but not yet. So you can see the new cases and the new deaths with YVal. So you can see with widespread, you can see the new cases and the new deaths. It's in an array. And then what we want to do is we have to portion out the columns. So column 0 is the new cases, column 1 is the new deaths. Then what we do is we put our new cases on a chart, and you can see it's not a very good chart to look at. We put our new deaths on a chart, and that's not a very good chart to look at either. So now what we've done is we put our predictions on a data frame so you can compare the actual cases with the predicted cases and the actual deaths with the predicted tests. And so you can see what you think of that. Now, after we've done our prediction on the validation set, then what we're going to do is we're going to create a test set. So test equals last date, test date equals next day, test. So you can see that we've created another data set calling it test. It's 191 rows by 53 columns, and you can see the date is today's date, which is 27 December 2020, which is because yesterday the last date was 26 December. We're doing the next date, so the next date is 27 December. So what we're doing is we're predicting on the next date. I'm sorry, I can't predict on the next month at this time. We're only predicting on the next date. So now what we do is we convert our date to a number. Test date num equals test date dot dt dot strf time, and then the format tests. And you can see what we've done here. So we've converted that date to a number. So again, it's 27 December 2020, but it's converted to a number. Now what we want to do is we want to check for any null values in the test set, and you can see that there's quite a few null values that have to be imputed. So what we're going to do is we're going to impute the missing values. So predict date equals test date, test equals test dot drop date. So we drop the date from the column. And what we want to do is we want to check to see how many columns are not numeric. And so we get a list of that, and we impute all of those columns that are not numeric and just put not listed in all the null values. Now that all of the columns that are not numeric have been have been imputed, then what we can do now is we can just say test fill in a 0 in place. So everything in the numeric columns that doesn't have a value, we just put 0 in there. So now what we want to do is we want to ordinal encode. We want to ordinal encode all of our non-numeric columns. So test country equals test location, test country. And then so what we've done here is we ordinal encoded all of the non-numeric columns, just like we did in the train set. And now what we want to do is we want to define X test. So ISO code equals test ISO code, and then you've got X test equals test, dropping all of those columns that were relating to death and new cases. Now we put the test set on a standard scalar. So X test equals scalar dot transform X test. And so now you can see X test as it's been put on a standard scalar. Now what we want to do is we want to predict on the test set. So prediction equals model predict X test. Prediction equals prediction dot s type int. Prediction less than 0 equals 0. Prediction shape You can see it's 191 times 2 columns. Now we want to put our predictions in a data frame. We created a data frame for this purpose. So the data frame says country, predicted date, which is today, 27/12/2020, and then predicted cases and predicted deaths. So what you'll have to do is tomorrow you can go through the data set and you can compare the predictions that we made today with what actually happened. And then what that would do is that would give you an accuracy. So that will tell you whether this computer program is accurate or not. But I did it to the best of my ability. And obviously I don't know how many new cases and new deaths that we're going to have today. So we'll just have to wait until tomorrow and see. So this concludes the code review. So if you like my video, please like, subscribe, and share. If you like the work I do and you would like to make a donation, then I've got my email address to my PayPal account in the description box down below. And thank you so much for watching my video with the code review. And I look forward to making new videos for you.